Let me first thank you for watching my videos. In this video, we'll discuss optimization question. We need to minimize the length of the wire. There are three techniques, rather algorithms which are being used. We'll find which is the best one and then solve the problem. I hope you'll find the approach interesting and useful. Let us enjoy the journey of learning with Anil Kumar. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we are going to discuss a very important question based on optimization. So, in calculus, solving optimization applications, we follow algorithms. We also discuss the algorithm to follow for this particular example. I have three variations of the algorithm which can be used as per the question itself. Let's try to understand the problem here. The question here is two posts, one 12 feet high and the other 28 feet high, stand 30 feet apart. So these are the two posts, 12 and 28 feet high, 20 feet apart, 30 feet apart. The posts are braced by a wire from the top of each. So that is the wire which we are looking at. Post connected to a stake on the ground in between the posts. Where should the stake be placed to use the least amount of wire? So this is the stake which is to be placed somewhere within this 30 feet so that the wire is of shortest length. Find the length of least amount of wire. That's the question for you. You can always pause the video, answer the question, and then look into my suggestions. So let us try to correlate what we need to figure out. Fortunately, the figure is given to us. We have most of the variables there. Now, the thing which we need to find is the least amount of wire. So, this wire length. So, we'll define a variable. Let the wire length be L, and all these dimensions are in feet, so we'll write feet. Correct. Now, the step involved are we need to find this length of the wire. Let us relate it, imagining this is the point from where the stake distance is x. Then, for the 12 feet pole, it will be 30 minus x, correct? So that makes the total distance. Length L of the wire can be written as, let's label this point as A and B, stake as S. So AS plus BS. Using Pythagorean theorem, we can write AS as square root of 12 square plus 30 minus x whole square. And that of S to B will be square root of x square plus 28 square, correct? So this is the length which we need to minimize. We have length as a function of x. I could also write this as L of x, correct? So that becomes the length as a function of x. Let us just review the algorithm which we are going to follow. So as discussed in many of our videos earlier, the algorithm for finding optimization or solving optimization problems, in this case minimum length, is first we need to identify what is to be optimized. the length of the wire in this case. Draw a diagram to understand the situation. The diagram is given to us. Define the related variables. So we have defined L. Write the function in one variable. We got this function L of x in terms of x, the distance from the bigger post. And then we have three different ways of solving further, but common step being you need to find a critical number, that is, the derivative is zero or it does not exist. So once you have a critical point, then either you can find the absolute optimum point. So for that, you should know closed interval. So a closed interval from A to B. In our case, we do have a closed interval for x. It is from 0 to 30, right? Because that distance from the post can be 0 up to 30 maximum. We could also adopt the first derivative for minimum. The first derivative will be decreasing till the critical point and then increasing, right? So this is the first derivative test, which gives us minimum. Second derivative, to get the minimum, has to be positive, right? So second derivative should be positive, then only you get a minimum. So these are three different ways. In our situation, we find that absolute optimum is easy to figure out. Correct. So let's do that part. So we, in this particular case, also know that length L is from 0 to 30 feet, right? So we'll use the absolute value proposition since we are working in a closed interval. So let's find the derivative of the function, which is length of the wire in terms of x. So the first part will be 1 over 2 square root of everything, correct? Which is 12 square plus 30 minus x whole square times the derivative of inside function, which is 2 times 30 minus x times minus 1, so I'm writing minus here, right? Plus derivative of the other function, so 1 over 2 square root of x square plus 28 square, right? And the derivative of inside function is 2x. So that becomes the derivative of the given function. We can simplify this, cancelling these 2's, right? So we have the derivative as minus 30 minus x over square root of 12 square times 30 minus x whole square plus x over square root of x square plus 28 square. Clear? Now to find the critical number, we'll equate this to 0 and then find the value of x to get the critical number. So I hope this step is absolutely clear, right? Let's move on to the next page and see how do we solve further. So we just got an expression that the derivative is equal to. So we got two parts where x over x square plus 28 square is equal to, we can write 30 minus x over the other part, correct? So we write this as x over x square plus 28 square, right, should be equal to the other part 30 minus x over 12 square plus, there should be plus here, right? Yeah. So equals to 30 minus x over 12 square plus 28 minus x whole square, right? So, or 30 minus x whole square. Correct. Since the derivative is 0, to find the critical number, taking this term on the right hand side, we get x over x square plus 28 square equals to 30 minus x over 12 square plus 30 minus x whole square, right? Yeah, we have very limited space to work with. So now we'll just cross multiply and then solve, right? So let's do that part. So we have x times square root of 12 square plus 30 minus x whole square equals to 30 minus x whole times square root of x square plus 28 square, correct? Now we can square both sides. So once we square both sides, we get x square times 12 square plus 30 minus x whole square equals to 30 minus x whole square times x square plus 28 square. Clear? So we just squared both sides to get rid of the square root. Now you can see that x square times 30 minus x square will cancel, right? And therefore, we are left with 12 square times x square, right, equals to 30 minus x whole square times 28 square. Makes sense, right? So this way, I have actually provided you a very beautiful way of solving this, right? So now, since all are squares, we can square root once again and solve further. So we get our equation 12x equals to 30 minus x times 28. Do you see that? How simple it has become, right? So 12x is 30 minus x into 28. So let's write down here 12x equals to 30 minus x into 28. Open the bracket, so we get 12x equals to 30 times 28 minus 28x. 12x plus 28 x equals to 30 times 28, and that is how much? 0 and 40, right? Equals to, we can write 30 times 28 here. So x is equal to 30 times 28 divided by 40, correct? So let's do this math. 0, 0 cancel, and 4 goes 7 times. So we get 21. So 3 times 7. So x is, our critical number is 7. So we got the length from here to this point as 7, right? So basically, something like this, right? Okay, so that will give us the minimum length. Now we need to verify this. How do we do that? Now we have got the critical number C, which is 21, right? Critical number. We need to verify whether this is minimal or not. That means we'll find the length when x is 0, we'll find the length when x is 30, and also when L is 21. Let's do it on the next page. Perfect. So I hope you have understood these strategies clearly, right? So now we know the length formula. Length as a function of x, which we worked out, was square root of 12 square plus 30 minus x whole square plus the other length, which is square root of 28 square plus x square, right? Where for us this is x, correct? And that one is 30 minus x. So let's find when x is equal to 0. So we know x is between 0 and 30. Let me write like this. In feet. So when you substitute 0 here, you get square root of 12 square plus 30 square plus square root of 28 square plus 0 square, right? So just 20 square, right? Correct. Now if I substitute 30, in that case we get square root of 12 square, which is 12, plus square root of 28 square plus 30 square. And lastly, let's substitute 21. So we get square root of 12 square plus 30 minus 21 whole square, right? Plus square root of 28 square plus 21 square, correct? Let's find each value using the calculator. So you can also compare but let's use calculator to find the value, right? Now, 12 square plus 30 square and then square root of this. Then to this, we are going to add 28, right? It gives us a value, 60.3. The next one is 12 plus square root of 28 square plus 30 square. And that is equal to 53 point, so we can write 53.04, right? The lastly we have is 12 square within brackets 30 minus 21 square, and we'll square root this, plus square root of 28 square plus 21 square. So that gives us a value of 50. So we see that the minimum length is 50 in this particular case. That's the absolute value, correct? So find the length of the least amount of wire. So minimal least amount of wire required is 50 feet. You see, that is how we are going to solve this particular question. The tricky part here is, of course, to solve for the critical number because of those radicals involved. I hope you understand and appreciate the method. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. A request from Anil Kumar. We need your support for quality education worldwide. Anyone, anytime can support us. Every dollar counts. Please contact on the email globalmathinstitute@gmail.com. Thanks. Have a great day.